Afternoon. So welcome to one more video on the topic of resultant. Okay, so this is pertaining to vectors and mechanics. Okay, so you will use it pretty often. So the situation is that you have this octagon, and this octagon, there are three diagonals of the octagon that represent three forces. You're supposed to find the resultant of this force, and this force. Okay, the three forces, and you're supposed to draw their, find the resultant and its direction. So your goal is to find resultant, okay, and you are expected to find the direction of the resultant. Now, the problem is not the concept of resultant and direction. I think you can do resolution. The problem is, since this is an octagon, a lot of people would struggle because the knowledge of trigonometry would be lacking. So let's understand the octagon. Now, if you remember, the octagon, if you draw all these diagonals, I'm just completing the shape of a octagon. So this, if you draw the first one too, which is not part of the force, this is not a force. I'm just trying to explain your geometry. This angle, the whole angle is 135 degrees, right? So which is the internal angle, the internal angle of an octagon, right? So that is pretty well like taught in class 8th or 9th, right? So, but if you look into this angle number 1, 2, 3, 4, 5, and maybe 6, so segment number 1, 2, 3, 4, 5, 6, each one of them, is 135 degrees divided by 6 is equal to 22.5 degrees.
All right, so now we know that each small component is 22.5 degrees, right? So let's look at 6 newtons, right? 6 newtons, and then let's count the total number of subdivisions of this 135 degrees. So we have 6 subdivisions. We have already divided it by 6. So if you look at 6 Newton is at an angle of 22.5 plus 22.5 that you can see, with respect to horizontal. So I'm drawing a horizontal line. The horizontal line, now you have to calculate the angle made by the force with the x-axis. You can see each subdivision of 135 degrees is 22.5. So calculate the number of subdivisions for 6 newtons, right? So 6 newtons, how many subdivisions are there? You can see from x-axis 2, right? So it is 45 degrees. One and the second one is this, right? So let's look at 8 newtons now. 8 newtons, again 1, 2 and 3. So you have 3 subdivisions, which is 67.5. The aim is to find the angle of each of the force with x-axis. Let's do the same thing for 4 newtons. Now for 4 newtons, the number of divisions have been calculated, multiplied by 22.5. 5 subdivisions are there. The total subdivisions we've calculated is 6. So let's calculate this. This comes out to be 112.5 degrees. Now we know the angle made by each vector. Vector means the force represented by a vector. And this is the first step, right? The approach we are taking to solve this problem is the approach of resolution of force. So I am now going to divide this 6 Newton, 8 Newton, 4 Newton, making an angle of 45, 67.5, and the last one is 112.5 in x and y component. So let's look at 6 Newton, which is making 45 degrees, 2 components. The opposite component is the sine component. Okay, x component, the base is 45 degrees. Similarly, I will do this for 8 newtons, right? Let's do it for 8 newtons. The 8 newtons is also getting split now. Let's straight away write it as 8 cos, and you can see the angle of 8, 67.5, 8 sine 67.5, right? So now we have started using the concept of resolution of vector. I have a full series on vectors which you must see, because you can see a lot of mechanics is depending on the knowledge of resolution, right? So resolution of force is very important. When we resolve a vector in x and y component, we use cos theta and sin theta, which is what I'm doing. Now I'm doing the resolution of 4 newtons. You can see 4 newtons is beyond 90 degrees, and therefore the directions of x and y for 4 newtons is different. So this is sine, this is cos, and I'm writing each of the individual components separately. The x component is being written separately. The y component is being written separately. Now I have broken each of the force given to me in x and y, right? What was the strategy that we adopted? The strategy we adopted was very simple. We found the angle made by the force with the x-axis. Using that, we started breaking the force in x and y. That is what we did. Okay. All right. So I'm just correcting the angle of 4. It is 112.5, which we calculated. Let's do summation of all the x-axis forces. So you can see there are 3 x-axis forces: 6 cos 45, 8 cos 67.5. Then let's do the addition of y components. And we know once we have x and y, the resultant is given by the square of the x component plus the square. Now it's purely Pythagoras theorem, right? As simple as that. This is a step number 1. And if you have to find the angle which the resultant makes with the x-axis, what you do is you write the fy divided by summation, obviously the magnitude divided by the magnitude of fx. This will fetch you the tan of angle which is made by the resultant with the x-axis. This is what you were supposed to do in the concept of resolution and the concept of finding the angle of the resultant is clear to you. This was a complicated problem because this had octagon, and I will talk a bit about octagon. It's very, very important figure. You can potentially get struck in an octagon. Let's talk about it. What's special about octagon? Thank you.
You are like struck because now what you get as a figure is a figure of octagon, and if you don't have sufficient knowledge of octagon, you may get struck. So if you're preparing for an exam like JEE, or you are preparing for an exam like NEET, or you are a student of any other board, which is IB board, or you're part of A-level physics, or you're doing honors in physics, and you're doing the topic of mechanics, I think a good strategy will always be to always concentrating on the concept of geometry. I think geometry helps you tremendously solve such numericals pretty fast. I hope this helped, and if you liked it, please send me your feedback. Thank you very much for your time, and thank you for your attention.